a lot of subjects in this video, and so I might ramble on a little bit and I might digress and so forth, so just please bear with me and I hope you'll find some useful content here. And I'm basically just winging this. I've got a handful of notes here of things I want to talk about, and so here goes. Now the first premise is that you have to accept is that this from one note to its octave, you have 12 equal pieces. So, for example, that's called, and by the way, that's called the chromatic scale. All of the notes in between a note. So, for example, the chromatic scale for D is just simply all the notes from one D to the other D. The chromatic scale on E is all the notes between the E's, and so forth. So you know that there are 12 notes to the scale. The octave is divided into 12 equal pieces. And that's actually a huge deal in music. It's actually fairly new. It's only been within the past 200 or 300 years that this concept has taken root, and only within maybe the past 150 or 200 years that pianos were tuned where the musical space between each note is identical. And so in other words, the pitch change between this E and this F is the same as between this B flat and this B. Every interval is the same, and this allows for transposition, modulation to different keys, all kinds of advanced concepts that were not available to musicians 300-400 years ago on a keyboard instrument, or even for that matter on stringed instruments, but because of the way they were tuned. Now this tuning system is called equal temperament, equal division of the octave. And so by contrast, you have different cultures all around the world, and the ancient Chinese had very sophisticated music, and this music survives today simply because they used bells as their primary instrument, and they didn't have harpsichords and things like that. But the ancient Chinese divided the octave. The octave is universal. Almost every culture recognizes the octave, and as I touched on in a previous video, it's just basically the idea that one thing is vibrating twice as fast as the other. So from this C to this C is going twice as fast as this one, and the sound is the same. The notes blend together. The ancient Chinese divided their octave into five pieces, not necessarily equal, but 5 pieces. So, and the most accessible example that we have for that on the keyboard is simply the 5 black keys. And you can just basically doodle around and almost come up with some Asian sounding music that way. But another example, and I'm not going to spend much time on this, the ancient Indian culture, country of India, had an octave divided into, I think it was 7 shrutis, which were then subdivided into about a dozen svartas. I may have those terms mixed up, I really don't know. It's not important for this discussion, but basically you had an octave that was divided into 20 pieces. So, and that wasn't unique to them. In the 16th century, they even had a harpsichord that was divided, I think this is in 18 pieces. You can see that from this C note you had a C a little bit sharp and a little bit sharper. There's 2 D notes, looks like 2 E flats, and so forth. So you had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 black keys, plus an extra one right here on top of this D, and you had the 7 white keys. So that was probably a pretty difficult instrument to play. But if you want to explore that, I'm not going to talk any further about that, but if you want to explore that, it's actually a fascinating subject, and there's been many books written about it. One of them you can look up on Amazon. It's called Temperament, and the subtitle is How Music Became a Battleground for the Great Minds of Western Civilization, and it gives you the history of how this equal temperament came to be. But needless to say, that's too much to get into here, and it's not really necessary to completely understand all of that if you're just trying to learn to play piano or you're trying to learn to play some other instrument. But just be aware that, for example, every musical instrument on any note is the same musical space for every other note. So if we say this is a fifth, from here to here, this is the 5th note of the C scale, what we call the perfect fifth. This sound, this interval, is the same for every other note. Fourths are the same. The thirds are the same. And so forth. The half steps are the same. So it's a very nicely divided octave. It looks like a clock. 12 notes arranged like a clock. Now, on my previous video, I talked about the major and minor scales. Now, the reason those are so important is because those are the scales that set the key signatures for every song. That's our basis for the key signatures. So if you see a key signature with 2 sharps, you know right away that most likely it's in the key of D major or the key of B minor. So watch that other video if you haven't already, if you're struggling with that concept. And I also talk about how those scales are based on 3 primary chords, the 1 chord, the 4 chord, and the 5 chord. And those are the 3 chords that, if you line up the notes that make those 3 chords, eliminate the duplicates, and list them out, you have the scale. So I'm not going to repeat that. I just hope you'll watch that video if it is something you're struggling with. So this concept of the equally divided octave came along pretty much in Bach's time, and it wasn't quite the same as what we have today. We have what we call equal temperament. He had well-tempered, which is a slightly different tuning system, but it was pretty close to what we've got now, and he ran with it. He loved it, and he wrote the prelude and fugues, 1 prelude and 1 fugue for each of the 12 major keys and each of the 12 minor keys, and that is your famous well-tempered clavier book. And it's pretty advanced music, and he basically was showing off the sounds of the various chords and things and keys and what could be done with them. And it was very influential on music up until present. So anyways, that is that as far as just a little brief explanation about the equal division of the octave into 12 notes. Now, if you have 12 things, you can divide those 12 things evenly several different ways. You can divide 12 into 2 sixes, 2 groups of 6, and that's your whole tone scale. You can divide the 12 notes into 4 equal pieces, and that would be 4 minor thirds. So, for example, you can divide it into 3 equal pieces, a pie that's divided into 3 equal pieces. You can divide it into 6 pieces, and you can divide it in half. And I'm going to spend a little bit of time right now talking about 2 of those divisions, and one of them is the tritone and the other one is the wholetone scale. Now the tritone divides the octave exactly in half. If you play C and then this other C, the note right smack in the middle is the tritone. There are 1, 2, 3, 4, 5 notes between here and here, and there are 1, 2, 3, 4, 5 notes in between here and here. So this tritone from C is the exact midpoint between the octave. Now, since there are 12 notes, there are 6 pairs of tritones, and studying and analyzing these tritones is of great benefit. The tritone is also, if you look at your famous circle of fifths, you'll find your tritone exactly on the other side. So the tritone for E flat is A. The tritone for C is F sharp. The tritone for G is D flat, and so forth. Now, there's a lot to be learned from the tritone. Now, the tritone is what we call a dissonant interval. It has a clash. In harmony, the definition of harmony is any 2 notes that play at the same time. So this is harmony. Those are what we call consonant harmony. They sound good together, they kind of blend together, and so forth. Now, dissonant harmony is when 2 notes clash. Now, by definition, you can only go 3 notes. Now, we're not talking about repeats. So, in other words, here's 4 notes. That's a C chord, obviously. And I played 2 C's. But we're talking about the number of individual notes, not notes that get repeated. You can repeat all the notes you want. You have 2 D's, 2 F sharps, and 2 A's, and you're still consonant if you play them all at the same time. But you can only go 3 notes, and that is to say a note, its fifth, a major third, or a minor third, and still be considered consonant. When you add a 7th or something like that, you're adding dissonance, and I'll talk about that later. Now, consonance and dissonance are the yin and yang of harmony. Dissonance is not a bad thing, it's a great thing. Without dissonance, you cannot have consonance. It's just, to think in musical terms, you need to be aware of consonance and dissonance, which combination of notes are consonant and which ones are dissonant, and so forth. So you can have 2 notes that are consonant. You can have 3 notes that are consonant, but that's all you can have. When you add a 4th, you've divided the octave again, and you're going to wind up with a dissonant interval. So, in other words, just for a quick example here, if I take this C major chord and add this B flat, which is the minor 7th, this would be the so-called dominant 7th chord for F, which is one of the most, that's the so-called 5-7 chord. For the key of C, it would be G, B, D, F. You have added, you actually added a tritone. So you've added dissonance. You've got dissonance between here and here. and you've got this tritone, which is dissonant. You've got consonant interval here, consonant interval here, consonant interval here, consonant interval here. But between here and here, you've got dissonance, and between here and here, you've got dissonance. So, anyways, that's a pretty deep subject in and of itself, but it's just something you should be aware of, and we're going to talk about it more later on. So anyways, the tritone is a very important interval. It's used widely in jazz. It's used to great effect in blues. It's used in that 5/7 chord. Every 5/7 chord has this tritone. And the nice thing about the tritone is it's a roadmap to your fourths and your fifths. So if I look at this one, then I know that if I advance, make this tritone a little wider, I've got a fifth. If I take this tritone and make it a little narrower, I've got a fourth. And it applies to both notes. So here's the tritone, C and F sharp for C and for F sharp. If I shrink or enlarge the space here, I've got the fifth of C and the fourth of C. Okay, so for the key of G flat or F sharp, here's the tritone. If I expand this, I've got the fifth, and I've got the fourth. The fourth of F sharp is B. The fourth of G flat is C flat. G flat, F sharp, for F sharp, the fifth is C sharp. For F sharp, the fourth is B. For G flat, the tritone here is C. The fifth is D flat. The fourth is C flat for G flat. So there are 6 pairs of tritones, and excuse me while I look at my notes here, what all I wanted to cover. Another description for the tritone is when we make an interval wider, we augment it. So this can be considered, this is a fourth. Make it a little wider, that's an augmented fourth. This is a fifth. If we make it a little smaller, we can call it the diminished fifth. The fifth is made smaller. Some people call it a flat 5. And so it just basically depends on the context that you're working with. But for this purpose, I'm going to call it strictly the tritone. And the tritone is also the furthest musical distance between any 2 notes. So here's the tritone right here for C. Now you say, well, I want G. So you've got this big space here, but you can pick up G down here. Okay. So the furthest away, and you can see that really well on the circle of fifths, the furthest away is the tritone from any note, D to A flat, because the space here that would go over to, say, the E flat can be accessed this way in a shorter distance. So the furthest distance between any 2 notes is the tritone. Now, in jazz, you have these tritone inversions. You have all kind of chords based on the tritone and so forth. The tritone itself is more or less avoided in classical music, although, like I say, it's part of this famous 5/7 chord. Tritone also makes it pretty easy to find say your blues scale. So your blues scale is C, a fourth, a tritone, fifth, and this minor third, and this minor seventh. And just about any combination that you play on those notes sounds kind of bluesy. So for E flat, for example, we got this minor third, you have the blues scale is your root note, minor third, fourth, tritone, fifth, minor seventh, and then the octave. Now, I keep saying major thirds, minor third, or minor seventh, major seventh, and all of that. I touched on a minute ago. Like I say, you're going to have to forgive me. I don't have this lesson is laid out quite as well as I would like to have it. But when we talk about a major third, for example, that is the third of the major scale. When we talk about the minor third, that is the third of the minor scale. So, for example, for F, the third note of the scale is the major third, A. For F, the minor third is A flat. The minor seventh for F, as part of the minor scale, is E flat. As part of the major scale, it's E. Now, this is the reason that you need to understand your major and minor scales, because that's the syntax of how music is described. So if it's a major third, it's part of the major scale. If it's a major seventh, it's part of the major scale. If it's a major sixth, it's part of the major scale. Minor sixth is part of the minor scale, and so forth. And this tells you how to accurately describe these intervals. So this is a minor sixth. The major sixth is here, and so forth. So I want you to get some more benefit of what you can learn from the tritone. And so I'm going to go through the series of 6 tritones here. And of course you understand what happens. You go back where you started. So there's 6 pairs of them. And a tritone is the distance of 2 minor thirds. So here's a minor third, there's another minor third. So the tritone is not included, even though it's included in your blues scale and your jazz scales and so on, it's not included in any of the major and minor scales. So the tritone is not a part of the major scale or the minor scale on any note. The best purpose for studying the tritone is it makes it possible to find your 4 and your 5 on any note. Like I say, if you shrink it or expand it or just skip across it, then you've got that 4th and 5th relationship. And so that's very helpful in the thought process. I'm going to pause here just a second and be back. Okay, so keep talking about these major and minor thirds. For those of you that don't want to take the time to maybe study your key signatures and scales and all that, or maybe want to put it off for a little while, minor third is simply start on one note and skip 2 notes and land on the next one. That's a minor third. If you skip 3 notes and land on the next one, that's a major third. Skipping these 3 notes and landing on the next one, that's a major third. So, talk about several intervals here: major, minor thirds, fifths, fourths, and the tritone. So, if the next one I want to talk about is the Wholetone scale, Now remember, a scale is simply a collection of notes. Any group of notes can become a scale. Even a chord is a scale, depending on how you want to look at it. So, there's dozens and hundreds of different scales and so forth that people use. It's just simply a collection of notes that divide the octave. Not necessarily equal. For example, your major and minor scales, those are unequal divisions of the octave. There are 7 notes. You can't divide 12 by 7 evenly, so you've got an unequal division of the octave. And for example, there's another important interval I'm going to touch on real briefly here, because it is important when discussing the wholetone scale, and that is the so-called major seventh. That's the 7th degree of any major scale. And that's what we call also the leading tone. If you listen to this scale, let's just do the F scale here. This 7th note of the scale, it kind of has a psychological feeling of completeness. So if I just play the scale, I'm not trying to make music here, I'm just playing the scale. When you hit that major 7th, it kind of has a wheelbarrow effect, like a guy lifting up on the handles of a wheelbarrow and just finishing out the scale. Now if you compare that to the wholetone scale, the wholetone scale feels like it could just go on and go on and go on. And same way with this, if you divide it into minor thirds and major thirds. So here's minor thirds. Oops, sorry. It has no feeling of completeness. It's like a ball rolling up and down a hill and that kind of thing. But this leading tone makes it sound like it's resolving, like it's finishing. Another thing too is when you look at your major chords, your third of any major chord is the leading tone to the 4th degree of the scale. So if this is my 1 chord for C, this is my 5 chord. Now your third on of the 5 chord is the leading tone to C. For F, for example, here's the F chord. Here's the 5 chord for F. This E is the leading tone to F, the major 7th of the F scale. So the wholetone scale divides the octave into 6 equal pieces. If you look at it on the circle of fifths, it's basically just every other note. C, D, E, F sharp, G sharp or A flat, A sharp or B flat, and C. So in other words, you've got 2 combinations, so G, A, B, D flat, E flat, and F, and back to G. So if you look at that, it's real easy to see on the keyboard. You have these 3 notes, and those 3 white keys on C, and then the 3 black notes there, and you've got these 2 black notes and these 4 white notes. Those are your 2 wholetone scales. Now, the wholetone scale, for example, on C sharp would be this. For E flat, it would be this. For E, it would be this. So you've only got really 2 sets of wholetone scales, because the other, you got a wholetone scale on every note, but it basically fits into one of 2 sets. And the wholetone scale is 3 pairs of tritones. So that's one set, and here's the other set. I'm sorry, I messed up. So there's these two notes, and these four, these three, and these three. So let me do it again since I messed it up. This one, this one, this one. So there's three pairs, and we're back to this. And so the three pairs of tritones give you 6 notes. There are 2 6-note scales which divide the octave into 6 equal pieces, and both of those scales are your whole tone scales. The whole tone scale is another way of looking at it, is just every other note. Every other note on the circle of fifths. Some observations about this scale. There are no fourths and no fifths. There are no leading tones, because every degree of the scale it skips a note. It has major thirds, messed up right there on that last one, but there are major thirds, but there are no minor thirds. So there's two parts of the whole tone scale. This one. But you don't have any minor thirds, and there are no leading tones. Every major and minor scale has 3 notes of one set and 4 notes of the other set. And so there's 7 notes in a major scale, 7 notes in a minor scale. Now 3 of those 7 notes will be from one of these sets, and there'll be 4 notes from the other set. Now this whole tone scale is a nice scale to work on. It will familiarize you with the keyboard in a real unique way, and it's kind of a fun scale to play and to finger, and it will help you with your thumb movements on the keyboard. So the way I finger it, there's probably different ways to do it, but every time I'm leaping from a white key to a black key, the white key I leap from, I play it with my thumb. Same way with this pair. So if I play the idea there, and that will help you with your thumb movements. But sitting down, this seems probably a little tedious to sit and think about these kind of things, but the more of this kind of analysis that you do, the more all of this will make sense to you. And I like to compare it to perhaps somebody that's learning any concept of mathematics, like say algebra or geometry or calculus or anything. He first has to learn his multiplication tables, his division tables, and that kind of thing. So sitting down and analyzing these whole tone scales, these tritones, these major thirds, these minor thirds, you're really not trying to make music at this point, but you are learning the fundamentals of these musical relationships. So if you'll bear with me here, because this does get a little bit confusing, even for me. I've been studying this for a little while, but just to rail these out for you, I might get a little mixed up, so be patient with me if I do. But just for example, I wanted to show, and this is something I found that would be kind of interesting. If I take each note and list it out, so C, C sharp, D, D sharp, E, F, F sharp, G, G sharp, A sharp, B. Now always remember that of course A sharp is the same as B flat. G sharp is the same as, or F sharp is the same as G flat. That when you do that, you list out these notes. It's interesting because we've established that there are two pairs, or two sets of wholetone scales. It's interesting that the combinations alternate back and forth. So the scale for C has 3 of set 1, 4 of set 2. C sharp has 4 of set 1, 3 of set 2. D has 3 of set 1, 4 of set 2, and so forth. So 3, 4, 4, 3, 3, 4, 4, 3, 3, 4, 4, 3. Now I'm not going to bore you by going through all of them, but let's just say, let me take about 3 or 4 of them here, and I'll show you how this works. So we know that the key of C major is this. Now its relative minor, of course, is the same set of notes but starting on A. So same notes. This is the A minor, and this is the C major. Now in terms of key signature, that's a key signature with no flats and no sharps. Now as far as your wholetone scales, C, the key of C, and the key of A minor both have 3 from, I'm going to call this one set 1, these 3 white keys, and those 3 black ones, and set 2 is these 2 black ones and these 4 white ones. Wish these birds would shut up. So the key of C major has 3 from the first set and 4 from the second set. The key of D has 3 from the first set. Remember, this is the set. So it has these 3 notes of that set, and it will have this one, this one, this one, and this one from the second set. Remember the second set, this is the first set, that's the second set. So it's got 4 from the second set, this one, this one here, and these 3, and from the first set it's got those 3. I'm sorry, these 3. For C sharp or D flat, you've got 4 from the scale. Another example would be the C sharp scale, and that one is this. And you can see that from set 2, I have 3 notes, those notes, and from set 1 I have 4 notes. Another example, the scale of G, which is here. That set is going to have 4 notes from this set, which would be these 3 and that one. From the other set of wholetone scale is going to be 3 of the notes, and that will be these 3. So there's a lot to be, a lot of good analysis that you can do with this wholetone scale. And remember, that's just simply every other note. And sitting down and analyzing this and putting together this little puzzle will help you learn these other scales. And so to wrap this up, we've got tritones, 6 pairs of tritones, 3 pairs of tritones make a wholetone scale. The tritone divides the octave in half. The wholetone scale divides the octave into 6 equal pieces. And sit and analyze that, and I'm going to make another video, 2 more videos here soon about this equal division of the octave. These are maybe perhaps a little more useful in practical expression of music. For example, the one that divides the octave into 3 equal pieces. That one's really handy because it's got that augmented fifth, and one of the things you can learn from this one, that I'll go into it in great depth, is the fact that you can take any of these notes and move them and you wind up with a major or minor chord. And so that's a pretty interesting effect. And so I'll talk about, on the next video, dividing the octave into 3 equal pieces. I'll talk about 4 equal pieces. And hopefully this will be of benefit to you. And if you have any questions, feel free to put them on the YouTube comments. And I hope you enjoy these videos, and I'll be making more soon.